We've already spent some time looking at random variables and defining random variables in different ways. And the one that I keep alluding to, maybe because it's one of the simplest definitions of a random variable, is one that's derived from a coin flip, maps the outcomes of a coin flip to some numbers, to a random variable. And so we could say that the random variable is equal to 1, or let's say it's equal to 0 if we get tails on my coin. And let's say if it's equal to 1 if I get heads on my coin. Now, the one thing that this random variable definition is not doing for us so far is telling us the probability of getting our random variable to be 0 or 1. And to get that information, we need something called a probability distribution. Probability distribution for this random variable essentially tells us the probability that we get any one of these outcomes. Now, is this a discrete or a continuous random variable? Well, the outcomes here are distinct. They are countable. You could list them. This is definitely a discrete random variable, so we will construct, or we will be taking a look at, a discrete probability distribution. Discrete probability distribution. So let's say someone says, okay, I've defined this random variable in some way for a given coin, and I'm going to give you the probability distribution. And so they come here and they start drawing this probability distribution. And most probability distributions, they tend to be depicted visually. And so here in the horizontal axis, I will plot all of the possible outcomes. So you can view this as kind of the outcomes for my random variable x. So the outcomes are either I'm going to get a 0 or 1. So 0 or 1. There's no other outcomes. I guess you could list other outcomes and just say they have a 0 probability of happening, but these are the ones that can actually happen. And then here on the vertical axis, I'll plot the probability of getting any one of those outcomes. And so the person tells you, okay, the probability of getting a 0 is 50%. 50%, so they draw a little bar here. It's like a histogram, a bar chart. And so this goes right up here to 50%, which I'll draw as a decimal, 0.5. And they tell you the probability of getting a 1, of the random variable becoming a 1, is 60%. 60%. Let me draw it just like that. 60% or 0.6. Now my question to you, and I know you're just starting to be exposed to probability distributions, but based on what you know about probability, is this a legitimate probability distribution? Well, let's think about what the probability of getting any one of these outcomes. So let's think about the probability that our random variable is equal to 0, or we're doing a union here, not an and, or the probability that our random variable is equal to 1. These are all of the possible outcomes. We're essentially saying, what's the probability that we get one of the possible outcomes for our random variable? Well, over here, we would just add the two probabilities. So the probability of this one right over here is 0.5. And then we're taking a union. And these are mutually exclusive events. So we can just add the two together. And then we have the probability of getting a 1. The probability of getting a 1 is 0.6. Actually, let me do that in a different color. Do it in blue. The blue is 0.6. And this strangely adds up to 1.1. Somehow saying that you have a 110% probability of getting any of the possible outcomes. This makes absolutely no sense. You cannot have a greater than 100% chance of having any one of the outcomes. If you're looking at all of the outcomes from a random variable, it should add up to 100%. So you point this out to the gentleman who's trying to tell you that this coin is defined in this way, or the probabilities are, and he says, oh, yes, I made a mistake. That was not the probability distribution. This right over here is not 0.5, 0.5. Let me clear it. Actually, let me clear this and redraw it. So he realizes that this was actually 0.4. 0.4. And now my question again to you is does this at least look like a legitimate probability distribution? Well, sure. The sums of the exclusive outcomes that this random variable can take on now equal to 1, 0.6, 0.4. And now the last thing I'll ask you, given what you know about this random variable, it's clearly an unfair coin. Are you more likely to get heads or tails? Well, the random variable, you're clearly more likely to get an outcome of 1. If you look at the definition of a random variable, the random variable will be 1 when your coin is heads. So it's clearly somehow the coin is weighted a little bit more probable to having heads. So I'll leave you there. In the next few videos, we'll study more and more probability distributions, which is really the core of probability. And we see it becomes a very helpful thing when we start to study inferential statistics.